Welcome back. So the next session is about energy monitoring, and my colleague Patrick Schmieder will tell you all about this. Like I said, this is all about energy saving, and today it's more than a hot topic. I'm sure in your private home or your office you have been looking into this. We're all about saving energy, saving money, and looking at nature. But how can we do this? Yeah, we have to measure the consumption, we have to analyze, and then we also have find a solution, fix it. And this is something that Patrick will not only talk about, but he will also give a live demonstration about this. So, Patrick, stage is yours.
Thank you very much, Jürgen, and hello everybody. I'm glad to have a presentation to you today about the topic of energy monitoring with the focus on produce sustainably and save costs, which is, in my opinion, a big topic in all of our private lives, but also the industrial energy consumption is a big part of the whole energy consumption in general. So it's important also to deal with this topic in your company. So I would like to give you some brief answers to the following 3 questions today. So the first question is, why energy monitoring? So I give you a little bit of background on why we're doing this. Second, how to monitor the energy consumption on the shop floor area. And last but not least, what can you do in the end to optimize your energy consumption on the shop floor area? So why energy monitoring? So the climate change is probably the topic of our generation for the next 10 years especially. This is, let's say, the crunch time. And within this context, it's really important that we reduce our energy consumption significantly. And energy monitoring is one part where I can derive special measures to reduce your energy consumption and receive an ISO 50001 certification. This is the certification for systematic energy management. Here you can see a picture of the SIG sustainability strategy. So SIG has a global sustainability strategy. So we want to be climate neutral organization until 2020. And this even includes our complete value chain. So our claim, our goal is to reduce the energy consumption of our customers and SIG as sustainability for us as whole company, internally and externally, is a super important topic. So what are the benefits, let's say also in short-term way for energy monitoring? So often we see a very fast return on investment through these derived measures. And may you all know, at least, our listeners from the European Union, that there are certain CO2 compensation fees, and these are significantly increasing fees from now on until 2030. For example, this year it is 25 euros, and I think in 2030 it's around 60 euros. So this is getting a more and more significant cost factor. So the cost, 60 euros, for example, is then per ton CO2. So, and benefits of energy monitoring, they really depend on local conditions. So it depends what is your government supporting this important topic. So I would like to ask you the question, how is it in your country? So this, and there you can see how big are the benefits in your country. So if we look, for example, on Germany, the benefits, they often depend on the standard, on the international standard ISO 50001, and therefore you need to have a continuous improvement. So within this PDCA cycle as an example in your energy consumption. So you have to really have continuously reduce your energy consumption. And what are the benefits in Germany then as an example? So what the government is doing is funding the companies to achieve this ISO 50001, to install energy management systems and components. So this is up to 40% on your investments. And also there are certain tax benefits which can reduce your energy costs by 50% or more. So in the end, reducing your energy consumption means double or even, let's say, triple savings regarding your energy costs. So, hold on a second. There we are. Sorry for this short break, but now we come to the question on how to monitor the energy consumption on shop floor areas. And especially I want to go more in detail into the example of compressed air. So first of all, we have the current situation that we often know how much electrical energy our compressor needs to produce this compressed air. But what is happening behind? What is my passive consumption of compressed air or behind the compressor, and what is in the end coming to my machine? So how much energy, how much compressed air consumption has my production or my machine? This is often still unknown. So as first solution, as first use case, we have the topic of data acquisition. So therefore, this is the basis. This is called the FTMG. It's a sensor by SIG, which is specially designed for these energy monitoring applications. And as user, it is important for me to integrate my collected sensor data myself as easy as possible into my system via IO-Link, via MQTT, or via OPC-UA directly into my overlaid system. So, and moreover, it is good to have an easy and fast visualization through an integrated web server. So if we look, the sensor is connected via MQTT or OPC-UA directly into the user system, and can also be directly accessed for a first data visualization via my browser. So this flow thermal measurement sensor for gases can directly give you a measurement data in kilowatt per hour, so in energy, and as well the data historics and the statistics I just mentioned with up to 7 days are directly stored on board of this sensor and can be visualized on this web server. So here I have a live example for you from our SIG production at a CNC machine. So as I told you, it's an important topic for us. We also installed this sensor plenty of times in our own production. So here you can see that the live data is coming. You can see the pressure and the volumetric flow rate. So as you can see, there's not happening a lot. So this means my machine is not running at the moment, yeah? And yeah, it's a live demonstration, so that can happen that in this moment the machine is not running. And what you can see here is the last 7 days. So for example, on June 5th, on June 6th, up to June 7th, you see that also my volumetric flow rate was 0, which is a good sign, as this was the weekend. and on the weekend the machine is obviously not running, and no volumetric flow rate means that I probably have no leakages in my pneumatic system. The pressure was quite stable, and I didn't, on the blue or the purple line, I didn't consume any energy. So to go to the next use case, this is getting, let's say, a little bit more complex, and this is also a use case where we have dedicated department at SICK to solve these kind of applications. So we have the topic of connectivity and also integration in this solution. So for me as user, it is important to connect all of my measuring points over, let's say, one plug-and-play data collector, and I want to receive my data every minute or every 5 minutes in a certain data structure which fits into my system, that I can easily integrate it into my whole production monitoring system, energy management system, or MES system. So if we look at the topology, so we have certain machines which are connected to edge gateway, for example, the TDCE by SICK, and on this TDCE is responsible for the right communication into the user system. So this TDCE has certain software module on it for this integration part into your user system, that the data is coming into the right quality and a stable quality in your system. What else is important for this solution is that we start with consulting first and with a proof of concept, as every system, every user system is somehow a little bit different. So we really have to look how is your production set to develop, to design the right solution, that we have an efficient energy monitoring in the end. So, and if we think this one further, as solution, then we also add software as a service. So as a user, this time it's important for me to have a turnkey solution to also directly visualize the consumption, the condition, or downtimes of my compressed air consumer on a dashboard. And also I would like to receive alerts to have a better planning of my maintenance to avoid extra costs. And here, beyond this gateway solution, I also have some a firewall to our cloud service, to the SICK cloud service, which you can access by your mobile devices or via desktop, or we can set up some kind of cloud-to-cloud connection that you can access it on your cloud. So as I said, turnkey solution with no programming by the customer needed by you. I have directly more transparency through this collection and visualization of this live and historical data. I can identify cost drivers through a certain anomaly detection, and also these mentioned configurable alarms. And as it is built up in modules, so a modular setup, you can also extend it with some more external data you need, like machine data or external data sources. What else? So how does this look like? So I have the dashboard first with my different FTMGs, my different flow sensors. So I see this sensor has a high mass flow rate. So I can look in detail on this sensor. I see the high mass flow rate. And then I can look at the data statistics. And what I see here is I have a significant higher mass flow rate, a significantly higher consumption of compressed air than in average. So if I had the same production volume, that means, okay, there should be something which is not right. So during my next downtime, my next planned downtime from my machine, I can have a look if there is directly some obvious leakages or anything else, or components which I can directly change then. So what can you do in the end to optimize your energy consumption? So first of all, let's talk about the over 100%, so about the leakages and overconsumption. You can identify and eliminate them. So yeah, but how do you do that? So if you go on systematically, you can first we can go with a 6-step process. So first of all, it's important to measure the energy consumption, the compressed air consumption, as close to the main distribution network as possible. So then I can have a look, what is my passive consumption? And here you can see it's round about 50 cubic meters per hour. So then in the second step I look, okay, what does that mean in terms of costs, in terms of cost per year? So to see how much can I save to see if certain measures make sense. Then on point 4, I can monitor the compressed air as close to the consumer as possible to really identify the leaks and repair them in the end. And if I compare the results in the end, I reduced it to 10 cubic meters per hour in my production area, which means an annual cost saving of over 7,000 euros. And moreover, I also have, through this continuous measurements, can optimize my maintenance processes through this data to avoid these costs in the future. So, and to reduce the energy consumption below the 100%, I can install a power on, power off management to identify times when you can shut down certain processes, certain machines, which are just not necessary. Then I have a compressor control. I can adjust that, I can improve that to use my compressors in the most efficient ways possible, depending on my production processes, with how much compressed air I need. And last but not least, a certain peak load management to have to lower down these high peaks, that I have just a little bit more stable energy consumption through maybe a time shifting of machine ramp-ups, for example, to have my whole infrastructure better adjusted to the energy consumption, which leads in a reduction in the end. So, to come to my conclusion, produce sustainability. So the leakages and the overconsumption, you can identify and eliminate them. Through continuous energy monitoring, you can derive measures to even reduce your energy consumption. And this data transparency helps to optimize your maintenance processes and to avoid downtimes, to make your machine processes more efficient. Save costs. So as mentioned, I can avoid these extra costs of leakages, overconsumption, and unplanned maintenance. And with this ISO 50001 certification, I can reduce my through reduced energy consumption. I have double savings, for example, through tax reliefs. And yeah, use your funding offers you have in your own country to have a cheaper investment into the future, into an energy reduction. And so I would like to encourage you in the end to act now and discuss this topic of energy consumption with us, because we have a scalable solution to reduce your energy consumption. So produce sustainably, save costs with SIG. Thank you very much.
Thanks, Patrick, for this great presentation and demonstration. Well, cost saving is of course important, but let's all save the birds and the bees. We like to go walking and cycling, especially the last 1.5 years. We have found out the forests again, so let's not forget this topic. I think you really had, you touched the audience because we had quite a few questions. We don't have too much time, but there is one, for instance, is it possible to embed your solution in your own ecosystem and just use data points to get all the information?
Yeah, so this was solution number 2, where we have this data acquisition, we have this integration, and this is quite a flexible solution. This is really, there we're looking at your system, at your needs. So certain needs, and maybe it is not, you're using a different sensor for maybe electrical energy. Yep. So it's possible to just to deliver also this integration service. Mm-hmm. So this is really looking at your needs, at your system. And so with the goal to integrate a certain energy monitoring solution into your ecosystem.
So to summarize, we can either provide a full solution or we can provide tools to get it implemented in your existing application or system at the moment. Okay.
Exactly.
I think you partly answered another question. Is it possible to monitor other energy forms than compressed air? I mean, the sensor, it does a few things, but I assume you can connect any other.
Exactly. So I already mentioned the electrical energy. So this is a topic we are already working on. And yeah, SIG is not producing a sensor for measuring the electrical energy. Mm-hmm. But yeah, we're also a software company now. So we're looking to integrate also these kind of third-party solution into our solution number 2, customized to your ecosystem, or as I said, in this third solution, in this turnkey solution, it is built up modular. So the next module, apart from compressed air, could be, or we're on the way to implement electrical energy.
Okay, thank you. I think it was clear, well understood. Thanks a lot for this presentation, and looking forward to save a lot of energy in the future. So the next one in a few minutes will be transparency and efficiency with easy IIoT upgrade. We'll be back in a few minutes, so hope to see you for the next session. Thank you.